In this video, we'll discuss linear classifiers. In particular, we'll discuss linear classifiers in general, and we'll talk about logistic regression. In logistic regression, we're trying to predict discrete classes. In this case, if y can equal 0 and 1. So we have a data matrix, and the different columns represent features, and the different rows represent samples. We also have a class vector, and this class vector can take on discrete values, which will represent with different colors. So in this case, we have the class red and the class blue. Every element in the class vector corresponds to a different row in the data matrix. We can plot these points in the number plane, where the different color represents the class. For example, sample x1, or the first sample, has a value of 4 and belongs to the class red. Sample x2 has a value of 1 and belongs to the class blue. Sample 3 belongs to the class green and has a value of 0. We can plot these points in the 3D plane as well. Like regression, we'll represent these with a matrix, where every row in the matrix represents a different sample. Our vector y will contain discrete values, in this case 0 and 1, and this will represent the actual class, i.e. the color in the previous example. Now let's talk about linear classifiers in general. The equation of a line in one dimension is given by the following, where we have the bias term and the slope term, and this generalizes to d dimensions. Let's see what happens for different values of x. We have the different classes, and we'll use the value of z to represent the value of the line. If we can separate the data with a line, we can then use that line to classify the sample. Let's look at our equation of a line, and everything on the right side of the line, if you put the value of z will be positive, and everything on the left side of the line, the value of z will be negative. Let's verify this with an example. Let's say we choose the value of x to be 3. We plug it into the line, and the value of z will be 2. Let's try another example. We have a value of x of negative 2. We plug it into the line, and we get a value of negative 3. If we use this line to calculate the class of the points, it will always return real numbers, such as negative 1, 3, negative 2, and so on. But we need a class between 0 and 1. How do we convert these numbers? We use something called the threshold function. If z is greater than 0, it will return a 1, and if z is less than 0, it will return a 0. Let's look at when we combine our linear classifier with the threshold function. Plug in the value of 3. The value of z is 2. We pass through the threshold function, and we get a 1. Similarly, if we plug in a value of negative 2, the value of z returns a negative 3. We pass through the threshold function, and we get a value of 0. Now let's talk about logistic regression. The logistic function looks similar to the threshold function. Here's the actual expression. If the value for z is a very large negative number, we get a 0. And for a very large positive number, we get a 1. And everything in the middle is around 0.5. So let's try our same value. We plug in a value of 3. We plug it into the line. The value of z is 2. We pass it through the threshold function. And if it's greater than 0.5, we return a 1. For the second class, we use a value of negative 2. We plug it into the equation of the line. We get a value of negative 3. We pass it through the sigmoid function. And we get a value for y equals 0. If the points are very close to the line, the value for the sigmoid function is very close to 0.5. And if it's far away, the value for the sigmoid function is either 0 or 1, respectively. The idea of a linear classifier generalizes to d dimensions, but instead of a line, we have a plane or hyperplane. If we look at the bird's eye view of the plane, i.e. where z equals 0, we can also see it as a line. We can use the same line to classify the points. If you're on one side of the plane, you'll get a negative value. Passing into the threshold function, you'll get a 0. And if you're the other side of the plane, you'll get a positive number. Passing into the threshold function, you'll get a 1. We can also use a logistic function. If the value for z is negative, we plug it into the logistic function, and if it's less than 0.5, our value is 0. Similarly, if the value for z is greater than 0, we plug it into the logistic function, and if the value for the logistic function is greater than 0.5, we get a 1. We can also represent the logistic function as a probability. Consider the following point. The probability that y equals 1 is given by the value of the logistic function. Similarly, we can get the value that y equals 0. We simply take the output of the logistic function and subtract 1. And this will give you the probability that our sample equals 0.